Ever feel like those robots in sci-fi movies? You know, they've got it easy. Never seem to struggle with software that just won't work together or communication breakdowns. But here in the real world, getting different tech, especially in robotics, to actually, like, talk, it's a real pain.
Oh, absolutely. It's the classic Tower of Babel problem, right? But instead of languages, it's sensors and actuators and code that just refuse to cooperate. And it's only getting tougher as we try to cram more specialized systems into our robots.
And that's where I think this Wrapyfi thing comes in. At least that's what I gathered, from the research we've done. This software tool that's supposed to bridge the gap between all these different robotics middleware.
Yeah, from what I've seen in their June 2024 documentation, version 0.4.44, they're taking a pretty interesting approach. Imagine writing all your code in Python, which, let's be honest, most of us are doing anyway. And it doesn't matter if your robot's running on ROS, ROS2, or even something completely different. Wrapyfi is supposed to just handle it.
Okay, so instead of having to rewrite like huge chunks of my code every time I want to test out a new sensor or algorithm.
Exactly. Think of Wrapyfi as like a universal translator for your code. You focus on what you want your code to do, and it takes care of how the nitty-gritty of interfacing with all these different systems.
So that part in the documentation about without altering your pipeline suddenly clicks. It's all about making the whole development process smoother, yeah. Especially with those multi-machine setups they keep mentioning.
Absolutely. That's where this really gets interesting. We're talking robot swarms, distributed sensor networks, the kind of complex systems that are becoming more and more common. Wrapyfi seems to be built for this future, where collaboration between really specialized components is just like essential.
Okay, but how does it actually work? They keep mentioning these decorators in your Python code. Now, I've dabbled in Python, so I kind of remember the term, but
Well, think of it this way. It's like attaching a little note to your code, instructions specifically for Wrapyfi about how to handle the communication part for that piece of code.
so instead of my code being cluttered with commands for ROS or 0MQ,
Exactly. You use a decorator to tell Wrapyfi, hey, this function here, it needs to send data over to my robot's arm, which speaks ROS. And Wrapyfi takes it from there, handles all the translation behind the scenes.
so as a developer, I can keep my code clean, focused on the task at hand, and I just let Wrapyfi worry about all the messy communication details. That's pretty elegant.
It is. And speaking of elegant, the sheer range of middleware and data formats this thing supports, it's impressive, to say the least.
Yeah, that supported format section in the docs is packed.
Yeah.
I mean, you've got ROS, ROS2, WireRP, pretty standard for robotics, right?
Yeah.
But then they've got 0MQ, which I always associate with those super high performance computing setups.
Exactly. And that really highlights how versatile Wrapyfi is aiming to be. And it's not just the middleware. They've also got the serializers. They talk about JSON, MSGPAC, protobuf, all these different ways to package data for transmission. And picking the right one can be critical, especially in robotics, where real-time performance is everything.
It's like they've really thought about what roboticists need, dealing with all sorts of different data coming in and time constraints.
And then there's the native object support. It's kind of mind-blowing how many data structures they've managed to include.
They can even handle pandas data frames. That's almost unheard of. Data scientists are going to love this.
Oh, I'd say so. It's a clear sign that they're thinking beyond just robotics. This has the potential to be a seriously powerful tool for anyone who works with systems that are complex and interconnected, sensor networks, machine learning clusters, you name it.
Okay, so we've established that Wrapyfi can handle a whole bunch of different middleware, data formats, the works. But what about the actual communication between these systems? How do they talk to each other? That's where argument passing comes in, yeah.
You got it. And this is where things get really clever. See, every piece of software, it has its own little quirks about how it likes to receive instructions. What Wrapyfi does is it translates these instructions. So a function that's written for one system, it can be called seamlessly from another system, even if they're speaking completely different technical languages.
Whoa, okay. That sounds incredibly complex. I almost don't want to ask, but how do they manage that?
Well, that's probably a whole other deep dive. The important thing to remember here is that Wrapyfi takes care of all that low-level translation. So you don't have to spend your time deciphering function signatures and data structures. It's like having a universal adapter for your code.
All right, so help me visualize this. Let's say I've got my code all structured, happily sending out instructions through Wrapyfi. How does it actually make sure everything's talking to each other the right way, orchestrating the whole communication side in my robot system.
Ah, that's where their communication patterns and those schemes they talk about come into play. Think of it like, I don't know, a playbook for how the information's going to flow between systems.
Right, right. The documentation mentions Popesly Cell VO and REQ/REP.
Hmm.
Those ring a bell, but a little refresher never hurts.
Sure, sure. Imagine you've got a LiDAR sensor on a robot, right? And it's constantly sending out this 3D map of everything around it. That's basically pub/SOB in action. One publisher, potentially tons of subscribers. Anything that needs that data, any part of the system can just subscribe to the LiDAR's, topic, and boom, they get those updates live.
So like a navigation algorithm could be subscribing to that LiDAR data to figure out a path, but then at the same time, a collision avoidance system is using that same data to make sure the robot doesn't run into anything.
Exactly. And here's the cool part. Because it's PU/SEB, you could later on add something else, say a mapping algorithm that's building a bigger, more complete map of the environment. And the original LiDAR, it doesn't even need to know. Seamless.
Okay, that's making a lot more sense. Now, what about REQ/REP? Give me a good robotics example for that one.
All right, let's say your robot's got to pick up a cup. Seems simple, but lots of back and forth, right? The control system might send a request, a REQ, to the arms controller saying, hey, move to these coordinates, grasp with this much force. The arm controller does its thing, then sends back a response, the REP. Could be object grasped or maybe grasp failed. It's that direct back and forth, like a conversation.
So POBSG, broadcasting, and REQ/REP is more about specific commands and getting confirmation. Gotcha.
What about these other things they mentioned? The mirroring, forwarding, channeling stuff?
Ah, right. So those are ways you can fine-tune how the information's flowing even further. With mirroring, think of it like making copies of important data, just in case.
Oh, so like if one connection goes down, you've got a backup for critical sensor readings and stuff. You got it. Forwarding, on the other hand, is more like a relay race. The data is passed from one system to the next, and along the way, each one can do its little bit of processing or filtering before passing it on to the next one. Imagine an image going through different stages, each one making it clearer.
In channeling, that one sounds kind of mysterious.
All right, imagine this. You've got a sensor, right? But it gives you two kinds of data, raw data, and then pre-processed stuff. Channeling lets you send those two streams to different parts of the system, whichever one needs what.
So some parts aren't overloaded with raw data they don't need. They just get the pre-processed info tailored for them. Slick. So with all these patterns and schemes, it seems like you've got a ton of flexibility in how you design the communication for your robot.
Absolutely. And that's where Wrapyfi's whole multi-machine setups thing really shines, because these communication patterns, they're not just for one robot. They can scale up. You can use them for distributed systems, even networks of robots all working together on the same task.
Speaking of scaling up, they also talk about plugins in the documentation. What are those all about?
Plugins, those are like Wrapyfi's superpower when it comes to like adapting to new stuff. Think of them as extra modules. You plug them in to teach Wrapyfi how to speak new languages or handle totally new kinds of data.
So let's say some fancy new sensor comes out and it's got its own weird way of communicating.
Right, right. You'd write a Wrapyfi plugin and it handles all that encoding and decoding of the data, so you don't have to rewrite your entire code base just to use this new sensor. It just works.
That's powerful stuff.
Mm-hmm.
So Wrapyfi can keep evolving with robotics as it changes. It's not some static tool. It's more like a platform for building these truly interoperable systems.
And that brings us to one of the most exciting things I've seen in the documentation. It's a potential in the world of AI and machine learning. That's huge.
They mentioned neural network sharding, right? I got to be honest, that one went a bit over my head.
It's a little technical, yeah. But basically, it's about breaking up a really big neural network, like splitting it into pieces so you can run it on multiple machines at the same time, speeds up the training and all that. And as AI models are getting more and more complex, that's becoming crucial.
So instead of being stuck with just one machine's processing power,
You use Wrapyfi to spread the work out. Each machine handles a piece of the puzzle. Opens up a lot of possibilities when it comes to training and using those big, complex AI models, and especially in robotics where we need things to happen in real time. That's a game changer.
okay, now that you mention it, I do remember seeing a bunch of specific robots and sensors listed throughout the documentation. It's like they've actually used this thing in real-world settings, not just theory.
Oh, yeah. They've put it through its paces. They mentioned the iCub humanoid robot, big in research for human-robot interaction and all that. Then there's Pepper, that commercial robot you see in stores sometimes. If Wrapyfi can handle both of those, that says a lot.
And it's not just the robots themselves. They talk about cameras, LiDAR, microphones. It seems like any sensor that spits out data could be part of this Wrapyfi system.
Exactly. It all comes back to what we were saying earlier. Wrapyfi is not just a robotics tool. It's much bigger than that. It can connect all sorts of hardware and software, making it super useful in any field where you've got complex systems that need to talk to each other.
So we've gone from worrying about robots bumping into things because they can't communicate to like a future where Wrapyfi might be the key to building these incredible interconnected systems. But gotta ask, with all this talk about connecting everything, doesn't that raise some red flags about security? Like all that data flying around, especially for things like healthcare or, robot surgery, that kind of makes me nervous.
You're right to be thinking about that. The documentation, I'll be honest, it doesn't get into the nitty-gritty of security measures. But dream on, as these systems built with Wrapyfi get more complex, more connected, strong security's got to be a top priority. It's non-negotiable.
Right. It's one thing if a research robot in a lab crashes because of a communication glitch. But if we're talking medical devices, a data breach could be disastrous. Lives are at stake.
Absolutely. And that's why developers, everyone involved, they've got to bake security in from the beginning. Can't just be about whether it works. Got to think about how easy it is to break into, how to keep that data safe, especially with all this connectivity.
It really feels like tools like Wrapyfi, they're kind of pushing us toward this future where the lines between like everything are getting blurry. Tech, different fields, even just the physical world and the digital world. It's kind of wild.
No doubt about it. It's both exciting and, yeah, a little scary. Exciting because of all the doors it opens, stuff we couldn't even imagine before. But scary because we need a whole new playbook, how we design software, how we integrate systems, even just cybersecurity. It's all got to evolve.
So after spending all this time digging into Wrapyfi, what's the big takeaway? What should we really be remembering from all of this?
I think the core message is this. Being able to connect different technologies easily, seamlessly, that's going to be the key to unlocking all sorts of crazy innovation going forward. And Wrapyfi, the way it handles this whole middleware mess, how flexible and scalable it's supposed to be, it's in a really good position to, like, dominate this new world we're entering.
It's not just about robots having a chat anymore, is it? We're talking systems where you can barely tell where the hardware ends and the software begins, where different fields are all smashing together, all that data flowing. Wild times.
And that's where the real power of something like Wrapyfi comes in. It's not just a band-aid for a technical problem. It's like they've created a tool that lets us imagine and build things that just weren't possible before. The possibilities are, well, they're pretty much endless.
So there you have it, folks. We've dived deep, we've explored, and hopefully we've got your brains buzzing about Wrapyfi and what it might mean for the future of, well, pretty much everything. Now it's your turn. What will you build with this power to connect anything and everything? Something to think about. Until next time, keep exploring, keep learning, keep diving deep. And we'll catch you on the next Deep Dive.